Prove that triangle ABC is congruent to triangle ADC. Alright, before we launch into this question, let's just have a look at some of the terminology that's being used here. This symbol here is when we are referring to a triangle, and usually there are 3 letters after this because the triangle basically has 3 vertices that we're talking about. So we're talking about the triangle ABC. Also, triangle ADC, this symbol here means congruent. So that means it's saying here, prove that this triangle is the same as this triangle here. Okay, and you would notice the ordering of these letters. They're not in alphabetical order. It says ADC rather than ACD, right? So if you consider ABC in this order, it's A, B, and C. So it's this point here, and then the right angle point, and then like you could call that the sharpest tip there, right? So this corresponds with the other vertices on the other triangle. So you've got A, and then D is the right angle, and then C is the sharpest point. So when we write a congruent statement, that's called a congruent statement, we really want for all of the vertices to correspond with each other. Okay, so we need to basically use this quite accurately. So we are proving this statement, and all a proof is basically giving evidence of something. So in this case, we're giving evidence for this statement here. We usually give 3 reasons why this is true, and I'm going to show you how to do that. Okay, so back in the other example, there were a few reasons why triangles were congruent. So I'll write them over here. Side, 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 side angle, angle, side, and right angle, hypotenuse, side. We're going to use one of these reasons for these 2 triangles here. So let's have a look at which ones we will use. Side, side, side. Well, we haven't really been given the markings of all the sides, so we can't use that one. Side, angle, side. We've been given, well, yeah, I guess we've been given 2 sides here. That and that are the same. That we know is the same, and those 2 angles are the same, so that's possible. Angle, angle, side. There's no 2 angles are being marked here, so that's not there. RHS. Right angle, we've got one of those. We've got a hypotenuse, which is also shared, and a side. Okay, so this one looks like it's going to be a little bit more specific. So we're going to choose this one here and get rid of that one. So our first reason, why are these triangles congruent? Okay, so the right angle we can see here. So we're going to start off with R. Right angle. This is a right angle, so is this here. So our terminology is angle B is equal to angle D, which is true. They are both equal to 90 degrees. Okay, so that's our first reason. Now we go to our H, hypotenuse. We can see the hypotenuse, which is the longest side in both of the triangles, is A and C. And A and C are exactly the same. We can see that, can't we? Because they're the same length. So we can say that A and C is common. Or we can say that they're shared. Okay, that's our second reason. And just like marked on the diagram, we can see that these 2 sides here are the same as well. So if we go ahead here, we can say A and B is equal to, now let's use our terminology, let's use our ordering correctly, A and B. So this point towards the right angle, A and B, here we're going to say is equal to, what do you think, D and A or A and D? So A towards the right angle, so AD. AD. So this is given to us in the diagram. And this here was also given to us in the diagram. Okay, now we finish off by stating the original statement here. triangle ABC is congruent to triangle ADC. And why? We know that because of RHS given above. Okay.